And so here we have these polar equations again, and these polar equations can also generate the hyperbola, and it depends on the eccentricity. So if the eccentricity is greater than 1, then we get a hyperbola. And recall that we get a parabola if the eccentricity is 1. But if the eccentricity is between 0 and 1, then we have an ellipse. And if it's greater than 1, then we have a hyperbola. And so now let's look at the graphs. And so here we have a hyperbola where the directrix is x equal to negative 10. And we have chosen the eccentricity to be 4. And to generate the points for the hyperbola, then it has to be like this. The distance from the point to the focus dividing by the distance from point to the directrix must equal to 4. And so we pick this point, then the distance from this point to the focus dividing by the distance from point to the directrix must equal to 4. And same thing, so for any point that's on the hyperbola, then the distance from the point to the focus divided by distance from point to the directrix must equal to 4. And so obviously if we choose another number like a 2, 3, 5 or something, then we get a different hyperbola. And the equation for the hyperbola is going to be eccentricity times the number 10. It comes from the directrix, and we want it's going to be the absolute value of this number, which is 10, and then 1 minus 4 cosine of theta, for 1 minus eccentricity times the cosine of theta. This type of equation is when the directrix is to the left of the pole. This is the pole right here. And then here's what we get when the directrix is x equal to negative 9. And notice we got a 9 here. And then again, the 4 is the eccentricity number. And then directrix x equal to negative 8. Directrix x equal to negative 7. Directrix x equal to negative 6. Negative x equal to negative 5. Negative 4. Negative 3, negative 2, and negative 1. And then once the directrix, once it's over to the other side, meaning it's to the right of the pole, then this will become 1 plus instead of 1 minus. And so here we have the directrix, x equal to 10. And so notice it'd be 1 plus eccentricity times cosine of theta. And here's directrix x equal to 9, x equal to 8, x equal to 7, x equal to 6, 5, 4, 3, 2, and 1. And then we have the type where the directrix is below the pole. If it's below, then it's going to be the type that's 1 minus eccentricity times the sine of theta. And again, the top is going to be just the eccentricity times the directrix number. The number coming from the directrix. Take the absolute value of this number. Is directrix y equal to negative 9, y equal to negative 8, y equal to negative 7, y equal to negative 6, negative 5, negative 4, negative 3, negative 2, negative 1. And then if the directrix, if it goes to the other side of the pole, meaning above the pole, and then this minus right here become plus. So let's look at that case. So here we have directrix y equal to 10. And so this right here becomes a plus. is directrix y equal to 9, directrix y equal to 8, directrix y equal to 7, directrix y equal to 6, directrix y equal to 4, and then 3, 2, and 1. So here's a summary of what we just did. So if the directrix, if it's below the pole, then we get the type as 1 minus eccentricity times sine of theta. If the directrix, if it's above the pole, then we get 1 plus eccentricity. We get ED divided by 1 plus eccentricity times sine of theta. And if the directrix is to the left of the pole, then the denominator here we get 1 minus eccentricity times cosine of theta. And the last case where the directrix is to the right of the pole, then for the denominator we get 1 plus E eccentricity times the cosine of theta.